you the cooperation between these agencies, making weather data available 24 hours a day and for every day of the year. Here, towards the end of January, you can see two cyclones forming in the southern Indian Ocean. And you can see how they grow. The eyes then develop really strong and then they dissipate over time. As we move towards the end of January, beginning of February, in the southern Indian Ocean, you'll see the storms forming most clearly. So of course we start the year with winter in the northern hemisphere and summer in the southern hemisphere. And you can see the difference between those two seasons clearly. In the north you can see those storms travelling across from west to east, bringing weather across the continental land masses. So you'll see storms travelling across the Atlantic and then travelling across the west of Europe. You can also see the storms travelling across the Pacific towards Western Canada, the US and Alaska. As we move into March, we're now in meteorological spring. So we will start to see the change in weather patterns. And what this is to do with is the angle of the sun as it hits the Earth. The sun would have previously been in the southern hemisphere and it's now moving very slowly towards the north. Again, at this time you can see a number of tropical cyclones, particularly just to the northeast of Australia. Tropical Cyclone Pam, around about the 12th of March, was an incredibly strong storm that affected Vanuatu. And just before that, around the 6th of March, there was Tropical Storm 15. And you can see there's a steady flow of storms travelling over towards the Philippines. This shows the importance of having these data so that forecasters are able to predict the storms and effectively warn populations that they are coming. So as we move from March into April, we come to the 1st of April, which is the birthday of monitoring of the Earth from space. The very first meteorological satellite, TIROS-1, was launched on April the 1st.